Hi guys, this is the second vectors video, and today we are going to use vectors to prove a very famous problem. And the problem goes as follows. We have any quadrilateral. It can be any type of quadrilateral like this type, or even like quadrilaterals that intersect itself, or something like that. And we first take the midpoints of each of its sides, as we see here. And we want to prove that if we connect the midpoints, then we create a parallelogram. So you can first try to prove it by yourself. Alright, ready? Let's begin. So first, when using vectors, I'd like to set an origin. It's not necessary, but it's nice to have an origin. So in this case, I'll just say this is origin. This is my origin O. And now we want to prove stuff that's based on a quadrilateral, and a quadrilateral is defined by its vertices. So let's name these vertices. Let's just call it A, B, C, where A, B, C are vectors. Now we want to go ahead and prove that the quadrilateral that we get when we connect the midpoints is a parallelogram. So in order to do this, we can prove that this side is equal to this side is equal to this side, and they have the same orientation. In other words, the angle that they have with like the x-axis or something like that is the same. So in order to prove that, we just have to prove that these two vectors right here, let me do it in a different color, right here, this vector and this vector are equal. If we prove that, then we prove that it's a parallelogram and we're done. So first we need to define these two vectors, and to do that we just have to define their endpoints. So this point first is obviously a over 2 because it's the midpoint between a and 0, the origin, and this point is just a plus b over 2. Similarly, we can see that this point is just c over 2, and this other point over here is b plus c over 2. Right. So now we've defined the endpoints of these two vectors. And now all you need to do is simply subtract the tail from the head to find the actual vector. For example, this vector is defined as a plus b over 2. This thing minus a over 2. And what's that? That's just b over 2. Alrighty then. Now let's look at the other vector. This vector is b plus c over 2. And then that, subtract c over 2. And what does that equal? That also equals b over 2. So therefore, these two vectors are actually the same thing. And therefore, they have the same length and orientation. And therefore, this is a parallelogram, and we are done.
Hey guys, it's Zong here. Today we're going to be tackling vectors. I wanted to do a video